Hello everyone, we've got this GCSE Maths paper from June 2023. It's a higher tier and it's paper 3 calculator. Off we go. Question 1. The line with equation y equals 2x plus 7 intersects the y-axis at A. Well, that's what it's called the intercept. So what we're looking at is, if you can't quite remember it, it's where it's going to cross there. So x equals 0, and what's the y value? Well, if we put x equals 0 into there, we're going to see it's this 7, because 0 times 2 will be 0. So y will be 7. Write down a fraction equivalent to 1.875, which is 1 in 7/8, but I know that from my engineering times, but we can use this. Go equals, and then there we go. Straight away, it's 15/8. And it's right, a fraction. We could go 15/8, but we can do a mixed number if we go shift there, 1 in 7/8. So we'll put that in. Okay. Solve 5x plus 11 equals 3x plus 19. We get all the x's one side, all the numbers the other. So we're going to go 5x minus 3x, because it's a 3x on this side here. We're going to take the 11 over this side, which is going to make it negative. 19 minus 11. So 5x minus 3x, 2x. 19 minus 11 is going to be 8. So x is 4. Just check it. 4 times 5 is 20, plus 11 is 31. 3 4s are 12, and 19 is 31. Question 4. A map has a scale of 1 to 5,000. How many meters are represented by a length of 4.5 centimeters on the map? Okay, so that's just 4.5 times 5,000, which is going to equal 22,500. That's centimeters. And there's 100 centimeters in a meter, which is how we've got to show it. So we need to come back 2 places here. So that's going to be meters. Okay. The number of hedgehogs in England is expected to reduce by 4% each year. Assume there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs in England after 5 years. You must show your working. We will use the compound interest formula, which can also be used for things going down in percentage. So we'll put down the original amount, which is 1 million. Times by 1, because we want to keep that original principle. And this time it's going to go down by 4 over 100 for our percentage. And it's going to be for 5 years. And that will give us our value of how many hedgehogs left. So we put it in like this. Close the bracket there. And then raise that bit, this one here, and put 5 in. We'll round it to the nearest hedgehog. Yeah. Here's a cuboid A. So a cuboid, not necessarily a cube. Cuboid B is made from 2 of cuboid A. Okay, there it is. Volume of A to volume of B is 1 to 2. Yeah, fine. Matthew says surface area of A to surface area of B must be 1 to 2 because B is made of 2 of A. Well, I would say, is Matthew correct? No. And I'm just going to put in there sides missing. where joined. Six sides. That'll do. Complete the table of values for y equals x squared plus 2x. So we put the minus 2 in there. Minus 2 squared is going to be positive 4. Minus 2 times minus 2, minus 4. So that's 0 there. And it's going to balance, isn't it? So it's got minus 1, 0, 3 there, minus 1, 0. This is where it's going to be 3, but we'll check it anyway. So we've got 1 squared is 1, plus 2 times 1 is 3. Yes, that's correct. We could use the table function. I'll just show you how to access that very quickly. Mode. Click 3 for table, and then you're into the table function now. We just put in, I'll put the x in here, alpha x, and that's a squared plus 2 alpha x there equals that. It's starting from minus 3. It's ending at 1. It's going up in steps of 1. And there it is. There's all our values. When minus 3, we got 3. If we go down all the way to 1, and at 1 we got 3, so it works. We'll change it back to computation. Now we've got to draw the graph of it. Okay, so it's minus 3, we've got 3. At minus 2, we've got 0. At minus 1, we've got minus 1. At 0, we've got 0. And at 1, we've got 3. Jing has 2,450. She saves some and gives the rest to her 4 brothers. Money saved to money given to brothers is 2 to 5. So that 2 is the money saved, 5 is the money given away. She gives each of her 4 brothers the same amount. Does each brother receive more than 430? You must show you're working. Well, we've got 2 there and 5 there. We've got 7 parts. This is how I like to do it. Find one part. We use the calculator, make it nice and easy. That's one part. Now the 5 parts get given to brothers. So total given to brothers, there's 350 times 5. That's the total amount say put out, but it's divided up between 4 brothers. So we're just going to go like that. Times 5, divide by 4. 4, 3, £7.50. Does each brother receive more than 430? Yes. The pie chart shows information about people at a fair during 3 days. There's Friday, Thursday, Saturday's got the most. There were 132 more people on Friday than on Thursday. So if I call that 25 in there. So this represents this bit in here, which is 55 degrees. Is that right? 55, 60, yes. 55 degrees equals 132 people, basically. So we can say that 1 degree equals 132 over 55. 2.4 people for 1 degree. And this here, we've got, work out the number of people on Saturday. Well, the number of people on Saturday is going to be 360 minus the other degrees, which is 80. plus that 25. And then we're going to times all of that by the 2.4. 612. Did I put it in the right place? Use trigonometry to work out the value of x. X is here. That's going to be the opposite. This is the adjacent. So we've got Sokotoa, and they're going to give some information about this on the formula sheet, but it's well worth knowing the order in which they go. We've got the adjacent, so we can only use cosine or tangent, and we need to find the opposite, so we're going to use this one. The way we write that out is tan 58 degrees equals the opposite over the adjacent, which equals x over 46. So it's going to be 46 tan 58 degrees. Put our answer in there. $73. And yes, we would expect it to be bigger than the 46 because the angle is bigger than 45. Question 11. Millie is estimating the value of 1 over this lot. She rounds each decimal number to one significant figure. Okay, we're rounding then. Oh, work out Millie's estimate. You must show all your working. So we've got to show it. So we're going to go 1 over cube root of, it's going to be 8. One significant figure. And that's, we'll put it all, oh, and then that's going to be squared times 10. Well, if you know your cube root of 8 is going to be 2, and 2 squared is going to be 4, times 10 is 40, so it's going to be 1 over 40. We can check it on the calculator. One over 40. Millie says my estimate must be more than the exact value. Without working out the exact value, give a reason how she can know this. Well, in each case you round down. A smaller number on the divisor will always give a larger number result. So I'm going to say question 12. Here is a bias spinner. Well, we can see red is a quarter of the total. We'd expect to get 3 times as many greens as red. Ali, Ben and Carrie want to know the probability of spinning red on the bias spinner. They each spin it and count how many times it lands on red and divide by the total number of spins. Ali says, I spun red the most times. Well, that doesn't tell us anything about green, does it? Ben says, I spun the spinner the most times. Well, the more times you do something, the more accurate you're going to find any bias. Carrie says, my relative frequency of red is 0.25. Well, how does he know that? And how many spins did he do? I'm going to say it's Ben. I think that's right. Okay. Dev spins the spinner 80 times. He says, my relative frequency of red is 0.185. Give a reason why his relative frequency must be wrong. Why is it must be wrong then? Well, let's see how many times it came up red then. 0.185 times 80. Well, that's the reason. 14 8 reds. Impossible. Must be a whole number. Eleanor spins the spinner 125 times. The relative frequency of red is 0.32. Work out how many times the spinner landed on green. Well, that's everything else. So it's going to be 1 minus 0.32 times 125. Equals 85 times. Question 13. Charlie is driving 293 miles home. He leaves at 9 a.m., travels the first 176 miles at an average speed of 48 miles per hour, drives the rest of the way at an average speed of 65 miles per hour. Will he be home by 2:30 p.m.? You must show you're working. Well, we just got to work out times then, haven't we? So if he's going 176 miles and he's doing 48 miles per hour, we just divide it by 48. It's going to give us our hours. Plus the rest of the way is 293 minus the 176 divided by 65. That's going to give us our total traveling time. It's 5.46 recurring hours. And 9 to 2:30 is 9 to 2:30 p.m. is equals 5.5 hours. Yes. Just in time. Because 5.46 is less than 5.5. Question 14. Kieran paid income tax and national insurance on her annual salary. Income tax is 0% of the first 12,570 of her annual salary, 20% of the rest of her annual salary. Okay. National insurance is 0% of the first 9,880 of her annual salary, 13.25% of the rest of her annual salary. Okay. Kieran paid £5,186 in income tax. How much national insurance did she pay? So we're going to use this figure, the income tax, to work out what her total pay was. Right, £5,186 was income tax, and that represents 20% once that amount is removed. So let's do this first. So that's going to give us our total. So if we went 5,186 divided by the 20, because that's the 20%, and then times that by 100. That's right. Gross salary. That's the gross salary. Okay, national insurance was 0% on the first amount and then 13.25% of the rest. So what we're going to do is take 9,880 off of that. So we do like this, 3,850 minus the 9,880. We're then going to take 13% of that. So we times that by 13.25 over 100. And that'd be the national insurance. Put that lot in a bracket, of course. Okay, let's do that. That's the national insurance. Quite a lot. Question 15. 180 runners started a marathon. Some of the runners did not complete it. Question 15a. The histogram represents the times of the runners who did complete the marathon. Okay. What's our question? How many runners did not complete the marathon? Okay, this is all the data. So the area of each of these contains how many runners completed in that particular interval there, 140 to 160 minutes. And we got a frequency density there of, that one is 5.6, 0.7, that one's 0.8. And we work out the number of runners by multiplying the frequency density by the interval there, which is, in this case, it's 20. I'm going to put them all down. That was 20, 60 to 80 is 20. 180 to 220 is 40. 220 to 260, 40. 260 to 320, that's 60. And we multiply each of these by the frequency density. So I'll put them all up there. So the first one is, that's 0.8. So we put that lot into the calculator. That equals 152 who completed. So the ones who didn't complete then are 180, which is the number who started the race, minus 152. 28. 15b. The table shows information about the runners who did not complete the marathon. So that's the distance they've run in miles. Least distance 5, greatest 23, lower quartile is 11, median's 18, interquartile range is 9. Draw a box plot to represent the information. Okay, so the least distance is 5, so that's going to be one end. Yeah. And the greatest distance is 23. So 20, so this is every 2. 23 is there. You be a bit careful with these. Okay, that's that. The median is 18. Okay. Lower quartile is 11. That's here. The interquartile range is 9. So that was 11. The interquartile, it's going to go up to 20 then, isn't it? 20 is here. So that's our box, basically. My ends didn't need to be quite as big. So we go, that's our median there. This is our lower quartile. This is our upper quartile. Okay. That should do it. Question 16. In this right-angle triangle, A is 16. Let's put that straight in, 16. A to C is 4 to 5. 16, 4 to 5. It's going to be, we multiply this is times 4. We have to times this one by 4. Be 16 to 20. That's 20. Work out the area of the triangle. Okay, if that's 16, this is 20. We're going to use, we need to know B, then we can use half the base times the height. So what we're going to do is we're going to say C squared equals A squared plus B squared. put in the things we know, 20 squared, this is Pythag, equals, and I just like to put it all in like this, 16 squared plus b squared, then move it around, the square root of 20 squared minus 16 squared equals b, equals 12. Quickly redraw it, 12, 16, area equals the half, base times the height, and put our answer straight in there. Okay. Question 17, solve x plus 8 over 2 plus 9 minus x over 5 equals 4. We've got to solve it for x. So let's find a common denominator, which is going to be 10. We've got to multiply this side by 2 and this one by 5. So we're going to do that. We're going to go 5 x plus 8 plus 2 times 9 minus x over, I'll go 2 times 5 for now, equals 4. And I'm going to move that up to the top like this and say 5x, 5 eighths of 40. I'm expanding these brackets, plus 2 nines, 18, minus 2x equals 10 times 4 is 40. Okay. 5x minus 2x, 3x, plus 40 plus 18 is 58, equals 40. We'll take the 58 over 3x equals 40 minus 58, which equals minus 18. Divide by 3. Divide by 3. X is going to be 3 divided into 18 is going to be 6. So it's minus 6. We check it. This here, we can do it this way. Minus 6 plus 8 is 2. 2 over 2 is 1. 9 minus a minus 6 is going to be 15. Over 5 is 3. 3 plus 1 is 4. That works. Yeah. Right, we've got a function x equals x squared plus 6x. And then we've got another function gx equals 2x plus 1. Show that function gx equals 4x squared plus 28x plus 40. The way you do this is where you see the 2x plus 4, for the gx, you stick that in wherever you see x. So it should work like this. So 2x plus 4 where we see x. That's squared, plus 6 times the same thing, 2x plus 4. We expand it out. We do it like this, just to show we know what we're... One way of doing it is you say square the first term, square the second term, twice the product of the two. But we show it like this, I think. We'll expand this one out. 6 2s are 12. 6 4s 24. This one we go like this, go underneath like this, equals 4x squared, and then plus 8x, and then this one, that one, and that one, plus, so plus another 8x over the top, plus 16, plus 12x, plus 24. So we end up with 4x squared plus You donate a 16 plus 12, 28x plus 40. Okay. So the whole of this equation, right, minus 5, not when x equals minus 5, it's when the whole equation equals minus 5. So 4x squared plus 28x plus 40. Move the minus 5 over, make it added on, so we go 0 equals 4x squared plus 28x plus 45. And we have to find the negative root as well. Delete that and put minus in. 9 over 2. 19. Two integers have a difference of 6. The integers are multiplied together. 9 is then added. Prove algebraically that the result is always a square number. But a difference of 6. So if we say that one of them is x plus 6 times by x, so the difference between those is 6. 9 is then added. Let's expand it out. X squared plus 6x plus 9 . Yes, because 3 3s are 9. Square the first term, x squared. Square the second term, 9. Twice the product of the two, 3x. Two of them is 6x, so that's what that comes to. Question 20a. Sunil thinks that E and D are linked by the equation E equals 36 over D. The graph shows the value of D and E for 2 is less than or equal to D, 2 less than or equal to 6. Okay. What's the question? Choose one point on the graph and state if Sunil's equation is correct for that point. We'll pick 4 because I know it's going to divide into 36. And at 4, it's 9. 9. So we can say 9 equals 36 over 4. Yes. 20b. G is directly proportional to the square root of h. Okay. G to h equals 3 to 2 when h equals 16. Work out G to h when h equals 100. Okay, so when h equals 16, so that's 16 on the 2. We'd have to 2 is times by 8, so 3 times 8 will equal 24, which equals G. So we can write this down as, we're going to go G equals, let's put the equation down first, K square root of h. G is directly proportional to the square root of h. It's going to have a constant in front of it. So put in what we know, 24 equals K root of 16. Root of 16 is going to be 4. So therefore, 24 over 4 equals our K value, which equals 6. Okay. Next thing is work out G to H when H equals 100. 6 root 100. So G equals 60. So that's 60 to the value of H, yeah, which is 100. Is that right? Yes, it is. We can take off some zeros. And we can have that as well. We can go 3 to 5. Yeah. A solid shape is made from centimeter cubes. The front elevation and side elevation of the shape are shown. There they are. Work out the maximum possible number of cubes in the shape and the minimum possible number of cubes in the shape. Well, the maximum is going to be this cross-sectional area of the front going all the way over this length here. Yeah, because that's this side. That side is on there. So it's only missing one square. Is that right? Missing one square off of there? 5 to 8. It's missing 3 here. And this is 2. So it's missing 6. Yeah, 3 2s are 6. So if we go 9 by 8, 9 times 8 minus 6, 9 8s are 72, minus 6, 66. Okay, so then that's 66 times this 12. So that's going to be 66 times 12. I'll put that in there, which equals 792. So that's the maximum. Now the minimum is going to be, if we looked at it, if we tried to draw it, we'd get this sort of shape. It's going to be one depth there. And then when it comes to here, it's going to come out, go in. It's then going to, yes, that's right. Then it's going to go down a couple, like this, and then out, and then down. Yes, that's right. Yeah. So we've got one way to look at this. We've got this lot patch on the front here, and then the rest of this, let's see if I can draw that down there. So we've got the same, we've got 1 times 66 for this end face here. Let's call that X equals that lot. And then we've got 1 less than this plus 9 times 1 less than the 12, because we've got this face taken off. 911, so that's 99, isn't it? So we got 66 plus 99. Well, I know what that is. 66 plus 99 is going to be 165. Let's just put them down there. 792, 165. Shape A and shape B are shown on the grid. Describe the single transformation that maps shape A to shape B. Well, they're not the same size, so it must be an enlargement. But also they're flipped over. So what it's going to be is, I can take this point here, corresponds this with this one here. So I can do a thing called array method. I can do this. 1 2, and this is 1 2 3 4. I think that should have gone through this point here. So there's our point. That's our point of reflection there, which is 7 4. Also, because it's flipping it over, and it's, I think we'd say that is minus a half. So I'm going to say, because it flips it the other way, rather than a normal enlargement, you just put the rays going up and it would just increase in size or reduce in size. It wouldn't actually flip it over. The fact that it's flipped it over, we say, I'll say it just like this. Yeah, that'll do. Question 23. A boat sails 35 kilometers north from A to B. There we go. From B, the boat sails to C and then back to A. So C and then back to A. Okay. Show that the distance the boat sails from C to A is 79 kilometers to the nearest kilometer. You must show your working. Okay. Well, it's either sine rule or cosine rule. And these are given on the formula sheet. I'll just put them up there. I'll redraw it and label it as they normally do. A, B, C, and this is an A in there. If this is 80, this one's 100. So we can say cosine of A equals B squared plus C squared minus A squared all over 2BC. Move this around for A. We're going to get, well, we'll have 2BC cos A equals B squared plus C squared minus A squared. I'm going to take the minus A squared over there, bring the 2BC cos A this side, and then square root it. So we'll end up with A equals the square root of B squared plus C squared minus 2BC cos A. And I'll put my values in. A equals, so B squared, what was our B when 35 squared plus 65 squared minus 2 times A equals 78.99, so 79 to nearest. 23B, work out the bearing of A from C. I think I'll redraw the triangle. Work out the bearing of A from C. So this is C, and the bearing's always clockwise from north, so it's this angle round here. If this is 100 here, then this one's 100. We've got to find this angle in here. We can then go 100 plus this, take it away from 360, and we're going to have the bearing. And for this, we're going to use the sine rule. We use sine C over 35. So this one over that one will equal the sine of 100 over 79. Move this 35 up, so we get sine C equals 35 sine 100 over 79. And then what we want then is the sine to the minus 1 of this will equal angle, which will equal, and we'll do this, we'll do it all in one go. $25.869, and then all we then do is we go 360 minus the 100 plus 25.869, and we'll put our answer down here, which is going to be our bearing. So 34.1. Finished. Thank you very much for watching. If you want to see more, then click a like, leave a comment if you've got any questions, and if you have not yet subscribed, then please subscribe, and I hope to speak to you again. Thank you very much.